All right. So first step is to identify what we're starting with. So go ahead and write down the initial quantity and then try identifying what it's asking you for and write down the units for that. I know it's much easier to watch me work, but you don't really get as much if you're not present and putting your brain into it. So that's what we're starting with. And the question is asking us for how much oxygen. You look for the question. This is the initial amount. How much oxygen? This is where we're going to. Our desired quantity. Whoops, I shouldn't have put it right there. I should need a little bit further over. Is we want grams, how much, of O2. What mass of O2 do we need? I just need a little more room because C6H12O6 is really big. So I'm going to go back to my mole island, my mole map. Once again, I'm going to start at mass, go to moles, convert from moles of one to moles of another, and then the mass. That's 1, 2, 3 steps. This chart is available for you on Canvas. You might want to have it in your notes if you're taking the final. I'm going to tell you the only normal years we mess with volume and molecules, but this year we're doing less than half of the normal work. This is the only path you will be expected to take. The problems will be just like today, just that one path. I'm making it easy because this has been imperfect. So we need 3 conversion factors. Smiley face here. The first one, you're going to go from mass to moles. The second one is your mole ratio. In the second one, you will relate the sugar, the C6H12O6, the moles, to the moles of O2 from the balanced chemical equation. And then the last one, you will take the moles of the sugar and convert it to, moles of the O2 and convert it to mass of the O2. And that should be your last thing on this side, should be grams of O2. So let's see if you can set this up. Oh, I'll give you one thing I will give you though. So that's tedious. How you find the molar mass of glucose is you take all, the carbon, you multiply it, the hydrogens and the oxygens, and you get, so I will give you this to make life easier. And just see if you can set it up. Don't even worry about and then I'll go over how to set it up. I'll go over it. This will just give me kind of a heat map of where we are and what's giving us trouble. If you just try to fill that in. And then I'll just a careful, because it gives students so much trouble. And I tend to run right through it. So we're going from mass to moles. So we want to cancel grams. 180.16 grams of C6H12O6 is equal to 1 mole. So this is just converting from grams to mole. Right here we have our mole ratio. Whoops. C6H12O6. I want to go from moles of the sugar to moles of oxygen. So I want moles of oxygen and moles of the sugar. Here's where we had the most trouble. This is where we have to look on the balanced chemical equation to see the relationship. There's 6 moles of oxygen and 1 mole of sugar. 6 and 1. Then we can go from moles to grams. 1 mole of O2 is 32 grams. That's the molar mass. That's from right here. I always check to make sure my units cancel. Grams, sugar, mole of the sugar, mole of the sugar, mole of the oxygen, and what's in the upper left corner matches what I'm looking for. And I got 13.3. Is that right? Oh, you guys got? Perfect. All right, so let's start looking at the gummy.